Thanks for coming. My name's Kieran Bingham. I work with Ideas on Board in Linux Media and V4L2 based projects. I spend most of my time working on Renesas projects, but because I'm heavily involved in Linux Media, we've been recently working on a community-driven project to tackle complex cameras, and that's what I'm going to talk about today. So in OSS Open Source Summit Japan last year, we had a gathering of the community to tackle this problem because we started hitting devices, complex devices for cameras in consumer equipment and even consumer laptops. So this has started to become a problem that's really biting us, and we needed to find a way to solve it across many platforms. A lot of this material is based on slides that were presented in ELCE by Laurent, and he had a 45-minute slot. So if you see a little kitten in the top, that means that's a reminder to me to skip on. And I didn't want to delete the slides because if you guys have questions, I want to be able to go back to the material. So Libcamera, it started out because cameras used to be simple. Maybe not too simple, but you could imagine a sensor connected to a SOC camera interface which exposes a single video device node. That means that there's a single point of control for the user space application. The application only has to deal with one video node, one place to look at the controls, one place to get the frames. Then we started finding devices like the OMAP 3, which was not simple. This is actually a media graph from about 10 years ago, so this shows the direction that it was headed 10 years ago. And we can see now, instead of just a single sensor with a scaler and a video node, we've got two sensor nodes exposed to sub-devices. We've got a flash. We've got various controls. We've got an ISP, which has multiple inputs and outputs. I think this one can do mem-to-mem, so you can really control the flow. And because we've got this now more complicated routing, we've got media controller involved. So now we've got another API to manage. And so the camera application has to know not only about just displaying a picture, but it has to configure the platform. It's got to talk on three APIs. We've got media controller, V4L2 sub-device, and V4L2 normal device. And that requires a lot of platform-specific knowledge, potentially in every camera application. And when that's platform-specific, it just doesn't scale. So, as I said, we got together in OSS Japan to try and tackle how to make this, how to simplify this. And we had about 15 of us in a room sketching out a design. And this is approximately what we came up with. So we want a common library which can tackle the platform-specific requirements of managing a camera. So we can see the Libcamera layer at the bottom. We're not touching the kernel APIs. We're using the existing kernel infrastructure, so we expect this stack to run on upstream kernel devices with a mainline kernel. We expect that there'll be language bindings added. We haven't done that work yet, but so that you can use your favorite toolkits. The Libcamera itself is written in C++, a language choice that was driven by reasons beyond my choice. We implement a Libcamera native API or interface, and that is essentially the functions exposed by the library. So if you wanted, you can write a Libcamera native application, and of course we have those as our test tools. Beyond that, we expect to expose a V4L2 interface so that existing applications, and that's actually one of our really important goals, we want existing V4L2 applications to be able to run on top of Libcamera without needing to know about the underlying platform. Beyond that, we anticipate writing a specific GStreamer plugin so that GStreamer can talk natively, but equally, GStreamer could also use the V4L2 wrapper. And of course, then we can look at using this same interface and write an Android HAL so that we can run on Android. Rather than looking at video devices as device nodes, as it happens with vFrail2, as trying to enumerate video/devs video 23, which is not quite so descriptive, we want to expose, or when you enumerate, you will expose a front and a back camera, perhaps, so they'll be named, and these will be defined by the platform. And the camera objects will manage that camera. So you might imagine that the front or the back camera has multiple streams to have a viewfinder or a live stream, and all of that will be wrapped up in a single object on the API. And that will, the camera objects will map the underlying complexities of the vFrail2 device nodes and the media controller and set it all up without you needing to understand the platform links. Each device is going to expose lots of controls and properties. We call those capabilities. And rather than having to manually set 300 controls, we'll expose, or the pipelines can expose profiles, so that you might just say, I want a video recording profile. And that will set up an assumed set of defaults. And you can then tweak the capabilities from there. I already touched briefly, we expect to have multiple streams. So each camera, once they're going through an ISP, as well as getting the full frame stream from the sensor, because you've got an ISP in there, you've probably got a rescaler, you might have the ability to have hardware accelerated resizes so that you can have a half frame, as you see the little fish at the top, as well as the full frame at the same time in real time. But not every device has to expose that, so you can still have, you could have two devices and only one of them would expose the streams. So the pipeline handler, it's up to the pipeline handler to expose what the capabilities of the hardware are. So streams are not mandated, but they are provided. We hope to have per frame, or we expect to have per frame controls on as much as the hardware can accept. And the idea there is that when you set a control on a frame, we expect that that frame, that control applies to that frame that you've requested. So we're following the request API and the way that the Android Camera HAL uses requests. Excuse me. Another important part of cameras is the algorithms to control that camera. In UVC cameras, for example, those are all contained in a black box. But now that we're on complex devices where all of that control is on the SoC, this has to be managed in software. So there's another main goal of Libcamera. So an ISP will generally provide, as well as the one or many streams, it's going to provide some statistics. And those statistics form part of the feedback loop and a control loop to handle the white balance, the auto gain, the auto exposure. And those statistics need to be fed back into the ISP so that the next frame can be of high quality. I've mentioned already we expect the Libcamera to have a couple of adaptation layers so that we can use vFrail2 natively, or native apps directly. And we want Android camera devices, Android camera apps to also be able to use this. So we'll provide a HAL. This is a quick look at the internal structure of the library, how we're planning it out. So we can see I'm going to go through that next. We can see we've got a camera device which has a lot of common infrastructure. Again, another part of this project is that we don't want everyone to have to repeatedly implement the same code over and over. So the state machine, managing multiple streams, access control for can two people open the camera at the same time, or can that user open it at the same once, is all handled in a generic code base. And we expect that to be common against all the platforms. Then in red, we can see there's a pipeline handler and the image processing algorithms. Those blocks represent the platform-specific code that's required to support a camera on any given platform. Now, the pipeline handler's job is going to be to set the camera up, and the image processing algorithms are where the are separated so that any vendor-specific code can control the processing. We'll have a camera devices manager, and this should support hot plug, so we can dynamically register cameras with the library. So imagine a UVC case, you can plug the USB camera in. We expect that camera to be exposed by the library. And equally, when you remove it, we don't want the whole thing to crash, so we already have that functionality working, and you can run a live stream, pull out a USB camera. The stream obviously stops, but nothing crashes. We just stop processing data. It's up to the pipeline handler to set the device stream up for the capabilities of the platform. And it will normally expose or it will use the hardware's CSI or input stream, and that will often go either to memory and then to an ISP, or it might be direct pipelining in the hardware. And then it's the pipeline's job to know what the capabilities of the ISP or the hardware is to generate multiple streams. So here you can see the ISP is outputting two video streams and a stats. So it would be represented in the camera as 3 streams of data. I'm sure I've seen that slide. The stats are then fed back into the 3A, and that controls the improvement, the video quality. And also in the image processing algorithms, that could also include video stabilization, for example. So anything that's part of the video control loop, that can go into the algorithm section. The important part about that is it's often vendor specific, or it may have had 10 years of research and development going into these algorithms to improve the camera quality. So we understand that the secret source can't necessarily be exposed, and Libcamera is a lesser GPL library. But we have a sandbox, and anything in blue box is excluded from the licensing requirements of the library. So you can put code in there which is proprietary and closed source, because we understand that camera vendors just can't release some of that information. And we don't want that to prohibit them using the library. We want this to be usable. That said, we will hope to then provide an open source implementation of our own 3A algorithms. And we hope that as it goes on, the community will improve those. And maybe one day, in 10 years, our implementations will be better than the vendors. Along with the, oh yeah?
What's so fantastic about this?
About
these algorithms? What is the selling point of them?
It's their value add.
Yeah.
Because I don't know, is the true answer. I think because of the nature that it's a control loop, it can be difficult to get right. For example, you might find that you're applying parameters and it might start to oscillate. And if you don't get those sort of things right, then you'll have visual perceptions in the video stream. So it's very important that people get this right. There's probably lots of maths involved. I know vendors spend a lot of time on this, and it's defined as their value add. So they keep it secret.
There's also some degree of taste in the results. So it's like, does this look quite right in the way you like? And some of the image people get very sensitive to, does this look warm and bright, like our image is always looking to look cool and relaxed like the other guy's images are. So we are pretty much in the same space as people doing, selling hi-fi equipment. Yeah, you get the same stuff. All the audio stuff is similar. The same amount of alchemy involved and so on.
Yes.
I pretty much made my point.
Okay, no worries. Okay, so yeah, secret source, we let them wrap it up in a box. We will provide, or we will implement as a requirement, a set of helpers and classes to support the library. So we can see we've got video for Linux API classes, media controller, so that all of this code doesn't have to be written again. You can just use the common framework. I said we support V4L2, so we're going to use an LD preload. So we will intercept the calls that the V4L2 application makes, the open, the arctors, and the nmaps, and we can wrap those into our API and do the right thing that's required for that platform. The Android camera HAL we know is going to be a big task. It's not going to be an easy thing to implement. So in our planning, we have aims to start simple and grow it as we can. So we'll start with a limited set of the API and implement more as we go along. And we have got support from Google, from the Android team. They will help us. So we hope that that will be a usable Android HAL. I'm running early. That's good. So this is a project that's been running for 4 months now. As I said, we met in Open Source Japan last summer. We managed to kick the project off, get started. We started developing code almost straight after ELC in Edinburgh. And we have code. The plumbing is now functional. So we can capture frames from an existing device and process them. So we can have a native Libcamera application running on our stack. Coming up next will be the, to explain, the project is going to take, is planned to take a year, so we expect the other uncolored blocks to come as they, over the coming months. Internally, we have done a good bulk of the common framework code that supports the plumbing. We've got a camera devices manager, so as I said, we can support hot plug. We've got state machine to track the running of the cameras. We've got the V4L2 and the media controller classes implemented. We've got debugging and logging. We've got multi-threading is about to be posted. And of course, we've actually got several pipeline handlers implemented already. We have not yet started working on the processing algorithms. That's coming up in the next milestone, I think. And we've actually got some guys that are going to help us with our first 3A algorithm, which we hope to be open source, which will be open source. So the pipelines that we've got currently are a UVC. Now that's maybe not a complex device, but it does, we'd still need to support UVC cameras, and it gives us a great starting point to start developing the library. VimC and Vivid are a great service provided by the kernel, so we can have virtual video devices and virtual media controller provided by the kernel, and we run our unit tests against those virtual devices, which means we can, on any commit, run a set of basic tests without needing hardware. The IPU3 is the Intel ISP, and that is in one of the devices that we were provided by Google, so that's our first real complex device that we're supporting. And as of yesterday, I think that went into our tree and merged. Raspberry Pi is the current platform I'm working on, and we're working directly with guys over at Raspberry Pi Foundation to get that supported. And then Rockchip is the next target that we're supporting. ... insert your company here. We want all of you to help us support your platforms. We would also like you to join the project. It's an open source project. You can collaborate with us. We want to know what you need from the project, what your use cases are. And as I said, we're 3 or 4 months into a year project. If you help us now, we can make sure that we go in the direction that meets your needs. If you participate in a year, we may have already gone down a different route. So we would really like you guys to get involved. If you're interested in cameras, if you want to run cameras on your SOC in specifics, we want to know what you want to use it for. We want to know how you're going to use it and what your... more importantly, we want you to support your platform and get the code into the library. If you adopt the library, out of the box, we hope that you will get Linux support, Chrome support, and Android support. And actually, as I've discovered, there are other cases, other libraries that are going to be able to use this, other frameworks, and then you'll be able to run your camera with those frameworks directly. So, if you want to contribute, we have a website at libcamera.org. Please go there. We don't require you to sign any contribution license or anything. We just follow the kernel or Linux media method of, we have a mailing list, we review patches on the list, and we integrate them after they're reviewed and tested. The source code is all available at linuxtv.org. That is the Linux media web hosting. So this code that's available right now today, you can run it on a UVC to try it out, which I'm going to try a quick live demo. Now, I'm sure you'll all be enthralled by this live demo because it is a webcam running, but the crucial part is, and it is just UVC, it's on my laptop, but that is going through our code base. So that's using all of our helpers, it's using all of our plumbing, and using a Qt framework to display the results. And I'm actually ahead of schedule, so do we have any questions?
So LED flashing is not in scope?
I'm sorry,
LED flashing lights, because it is critical for synchronization, such as TTL usage, or in front of a shutter period or in end of shutter period.
Yes, that will be supported by the pipeline handler. So the platform-specific code that knows it can enumerate the media controller, that's at the point where it can find a sub-device that has a flash. And actually, if you, on my first slide, I'm not going to go all the way back now, there were 3 sub-devices. One of those was a flash. So we do expect to support flash control. And so we have event handling in the library. So you could trigger an event and associate that with some code that would then fire the flash. But that would be platform-specific code, so that would live in the pipeline handler specific to that target.
Okay, and it should be in the same story of external flashing, such as trigger a Bluetooth signal, right?
If it was external Bluetooth, that would require some code, presumably the camera application, to know that how to talk to that external device.
But for the framework, the API or some callback mechanism is okay, right?
Yeah, I think so. We model the API around requests. So you should be able to set up a request with various controls. One of those controls could be enable the flash. And then when it gets activated by the camera, that would be a point of synchronization. Is that your concern, that being able to synchronize the flash to the point that the image is taken?
Yeah, in front of, for example, you have 1 millisecond and you want to synchronize the flashing in front of it.
In front of, okay.
Very short light.
I'd say that's a timing thing, and it's part of the control. Might be part of the control loops. It's definitely something that we will have to consider. It's not something we've done yet. As I said, we're only 3-4 months into the project. But again, that's exactly why I would love for you to send a mail to the mailing list and make sure that we do not forget your use case.
Okay, thank you.
Thank you. Any further questions? Great, so we're going to have all of you submitting code for your platforms very soon, especially you. Thank you very much.